All right, well, the controller's got a few more wires on it, but I've added some more really cool features that hopefully my buddy will really like. So let me show you. I think last time I made a video, I was waiting for these 10 mega ohm resistors to come in, and the idea here was to cut the amount of power draw that the system had. Instead of using 1 mega ohm resistors, 10 mega ohm resistors, and they worked just fine. I did have to find two of them in the pack that I got that had similar values. One was like 960 and another one was like 1020, and I needed to get two that were closer together. And once I did that, they cut the voltage in half for the LiPoly battery, and it read the battery voltage just as accurately as the 1 mega ohm ones did. And it cut the power draw by 2.5 microamps. So that was great, and it totally worked. And I had a second voltage divider, if you remember, over here. It was for the status pin of the charger. And the charger, what I did was made it so the status pin was pulled up to high, the high of the, or not high, but pulled up to the voltage of the battery pack, which would be 4.2 volts when it was fully charged. And I needed to have a voltage divider to cut that because that was more voltage than the 3.3 volts of the microcontroller board. So I had this idea of hooking up the status pin instead to the VCC of the microcontroller, pulling it high to that rather than the high of the battery. And that totally worked. So this green line here goes to a 10K resistor, if you can see it in there. And then on the other side of that 10K resistor is this red line, which is going to the VCC of the microcontroller buried in there. And yeah, that pulls it up to high. And then this yellow line here is just going to one of the digital inputs. And so that just goes high or low based upon if this LiPoly charger is actually charging up the battery or not. And that works just fine. So that was great. I was able to get rid of these three parts out of the circuit. So it looked really clean for a little bit, but then I started adding some more stuff. So I've got a photoresistor here, and what this is going to do is automatically adjust the brightness of the OLED display, so you don't have to manually do that, and that works great. And then I also got an RGB LED and all the resistors to sync the current on it. 1K resistor for the red, a 1K resistor for the green, and in the blue, it was very, very dim when I put a 1K on there. So I put I put 2 on there, and it made it a little bit brighter. And then I put 3, putting them in parallel. You're just using 1Ks, but putting them in parallel. Dropped the resistance even more to put more voltage through it. And when I got to 3, it made the brightness of the blue about equal to the green and the red. So so I'm keeping my parts count, low. I've got just using 1Ks here, 1Ks here. The photoresistor, I've got a 1K here. I do have a 10K for the pull-up on the status pin. And then on the transistor, I'm using 1Ks. I had 1K on here before, and I did notice another issue with the OLED display where it wasn't consistently working every single time. Sometimes the letters would get scrambled and the wrong pixel would light up and such. And I found that if I lowered the resistance by putting another resistor in parallel, another 1K in parallel, what's the word? It would saturate the transistor more. More current would be going through it because the resistance was lower, and more current would be able to get into the OLED, and that solved the problem. So now it's working 100% of the time. So I just got 2 of those in parallel, and then I got the 10 mega ohm resistors here. So I got my resistor count as low as I could get it because I ordered some surface mount parts. And I'm going to try to do a surface mount PCB like I did for the kitchen timer. I'm going to use Oshpark to make it, I think, but I'm going to try to use surface mount parts instead of through hole and see how that goes. So I've got some capacitors and some resistors. So that is going to be fun and cool and kind of the next step, you know, because I've got all the circuit board here, or the circuit design all finished, I think. So when it's all asleep, you can see it's drawing 81 microamps, and that's reading it right from the battery, and I don't have the programmer plugged in, so it's not doing anything goofy. So that's what it is when it's asleep. And then when I wake it up here, let me flip the power onto the other one here. Oh, let me put that over to milliamps. So when it's awake, and the amount of power draw really depends on how much text is being shown on the display, because each pixel lights up individually in OLED displays. So on the this water pump menu, I'm drawing 41 milliamps. And then if I go over to this LED color menu here, which has got a lot less text on it, it's only 21, or I'm sorry, 28 milliamps. So quite a big difference there. So this is just I can just control the LED color, red, then green, then blue, and I just did it so I could you know just see what the current draw would be like and stuff. I'm thinking on the box. So this is going to be a nice little wooden box to hold it all. I hope it's nice. I'm going to put, I don't know, maybe I'll put some holes in it and have like the LED shine through, or maybe have some holes in the back and it like project out on the back behind the box. Maybe I can show like the battery voltage in some way, if it's like green or red, that kind of thing. I'm just thinking of just another user interface item, having that little LED color change. So that would be kind of cool. And then here's the contrast. So you can do low or high and auto. So in low, for example, it's drawing 29 milliamps. On this display, it has less, different amount of text, right? And then high, 45 milliamps, so quite a bit. And so what I was thinking of with this photoresistor idea was making it automatic. And when you put on the on auto mode, I'm just showing the ambient light level that's detecting on that photoresistor. And this number goes between 0 and 1023. I might make that a percentage, but I just do the raw data right now. And if I shine a light on the photoresistor, and it goes above 300, the contrast goes from low to high. So if I move the light away, you can see it changing the contrast automatically. And so that's kind of neat. So if you take this controller outside and use it on the deck, it'll go real bright for you if it's outside at night, or outside during the day. And at night it will be low contrast. And then the battery voltage is the same, and it shows the charging state when you plug it in, so that's cool. And then on the water pump stuff, the one little feature that I added, which was not so little, was some of the air handling and the radio ID information. So right now it's on, and so once every 10 seconds it's pinging this and asking for status. And so if I were to flick the power off to this within 10 seconds, it will find out that, hey, I can't talk to it anymore, and it will say I can't communicate with the radio. So there it is, radio number 2 is the water pump. Can't talk to it right now. Now it's in a mode where it's an error mode. And once a second, it's trying to reestablish communication. And so I'll go and flick the power back on, and then very quickly, bam, it says, okay, it's off. So that works very good. Oh, and when you turn it off, when you turn this on, you'll see this LED here, this white one. It'll flash the ID number of this particular guy. So it's going to flash twice. Radio 2, 1, 2. There we go. So that's the indication of what number this one is. and I can reprogram the number that it is. Let me go ahead and turn it on. If I came with this little menu where there's a button here and you got this LED here, and if I click and hold, that'll go into the first menu, and if I click and hold again, that'll go into the next menu, and then so on and so forth. When you get to a menu, then you click quickly and to set the setting on that menu. So the first menu and the only menu right now is the radio ID menu. If I click and hold, it'll go into the radio ID menu, and then I can click what ID number I want it to be, from 1 to 9. So I'll change it to be 3. This is hard-coded to try to talk to 2 right now. I'll change it to be 3, and you'll see that the communication will fail because this thing is going to be on a new ID. And when it saves this, the number 3, it's going to flash this light 5 times. That indicates that it's going to save everything to the EEPROM that's built into the 18 mega chip there. And so then when you turn off the power and turn it back on again, it's going to read it, and it will be ID number 3, and it'll remember that. So let's go ahead and try it out. So I'll click and hold, and it will go into programming mode, and 1, 2, 3, and then we'll get 5 flashes here. All right, so now it's ID 3, and within 10 seconds, this will find out that it can't talk to the water pump anymore. Bam, so it's trying to talk to radio number 2, doesn't see it anymore. And so I will go into the first mode, and it just flashes once and then pauses. 1, 2, put it back on number 2, and then it will flash 5 times, and then this picks up on it very quickly because when it has that error, it just tries once a second. And it picks up right where it left off because this is still on. So that's being able to change the ID on this. So I probably won't have to do any updates to the program that's sitting on that microcontroller, but I will have to do some more programming for this. I would like to make a menu so that you could add more of these things to control, and so that means I got to have a way to like edit the text and edit the ID number for it, that sort of thing. But I think that's all software. I think on the hardware side, I'm all done, and I've got my pieces parts, and I just need to go and work on a circuit board and get that ordered, and go on my merry way. It's looking really good, and I didn't show it, but looks like I'm going to get half a year worth of battery life out of the 750 milliamp pack if this is used 6 times per day. Based upon the current consumption and all the basic measurements I'm doing here. So I think that'll be really good, and these batteries are not very expensive, so I think we're good to go on the battery side too. So that's about it.